Hi everyone, I'm Daniel, Scala software engineer here at Hivemind Technologies, and with me today is Ignacio.
Hello, how are you? Well, I'm Ignacio, software engineer at Hivemind too.
Yep, and today we're going to be discussing the wonderful article that Ignacio has written on the topic of ZLayers in the ZIO framework. So before we get stuck into his article and his accompanying application to have really dig into the construction of ZLayers and how they're utilized, and some really nice examples that is in our open GitHub that you can clone and check out for yourself. Let's have a quick chat about what problem exactly are ZLayers trying to achieve. Again, maybe you call them ZLayers in Britain. I am British, but for some reason I call them ZLayers. So ZLayers are, you can think of them as a form of dependency injection. So in many programming languages and libraries, we've dealt with dependency injection before. In one of my previous roles, we utilized Java Spring Beans for direct injection, dependency injection. ZIO approaches this in a bit of a different way. First, ZIO has the ZIO type, where all ZIO functions declare the ZIO type, which specifies 3 channels. So you've got, I'll kind of go backwards from this. So it starts with the output, which we're most used to with most functions. What is the output type of a certain function? And then going backwards through the ZIO type, we then have the error type. So you can think of this as much like an either. So you're either going to have the positive outcome, the type, an int, a string, or the error type, which could also be any type as well, an int, a string, or an exception. So far, so good. I think most Scala developers will be quite familiar with that as well. But then ZIO introduces the environment type. So you can think of this as what is the prerequisite object or class required, or an instance of an object or class required to run this effect to completion. Now, it might be the case you don't need anything, so you could have any in that channel equivalent to nothing. It will run without any external dependencies. But if you do require something, so for example, a database connection, you would put this in the environment channel. And this means the function, the effect, doesn't need to instantiate that instance itself. It will get passed down to it and use it when it's needed. So this is the ZIO type, and the dependency injection part, that environment, is achieved through the ZLayers functionality. And so yeah, that's a whole part of ZLayers. So let's get stuck into, first of all, how do we create ZLayers? So Ignacio, would you like to demonstrate for that for us, please?
Let me share my screen. The article has a repo that has a sample application. This is the repo, ZLayers article in Hivemind, in the Hivemind repos. Basically, we have a sample application in 4 different layers. You have the application layer, the service layer, and the repository layer, and a database. So, and you have different repositories, for example, a user repository, property service, user service and property service, user repository, property repository, and then the database using a config and a logger, and so on. So the idea of the application is to have something common in the commercial applications. This is for example, users having properties like houses and cars, or other properties. And we have this database containing all the information that these services will use, and the application will integrate the results of the different services into the results for the UI. So the idea is that some components depend on others. So let's go to the article, for example. Well, the ZIO data type is similar to the ZLayers data type is similar to ZIO. in the dependencies between components. We have an application, and we have services and repos objects, and we have to build the application into a graph, into a dependency graph. For that, for example, if you have a logger, a trade logger, define a log message, log method, and we have a logger implementation that requires a console to print those messages. Then we can build this instance in this way. We can have a logger implementation that requires a console and extends the trade logger. So this is the implementation of the log message. And then for building the ZLayer that requires a console, because we want to write to the console, cannot fail, because in this case it's very simple, and returns a logger if the ZLayer is successful, the building of the ZLayer. So
yeah, that's actually a very important topic. Quite often in applications, you have to construct layers from other layers from other layers, so you build up, as you said, this hierarchy, this graph. You can build them directly like this, so this was quite simple. One class needed one other class, but with larger applications it can balloon in complexity quite quickly, isn't that right?
Yeah, in this way, the most simple way of constructing a ZLayer is just let's see. Well, we cannot.
Oh yeah, that point there, as you had.
Well, we have
there.
This example is good, but it's not the most basic one.
Using the ZLayer, as you can see there, after the equals, using the ZLayer apply function here, and inside a for comprehension. Yep, that's pulling in using the ZIO.service. So that's actually declaring with the ZIO.service that it requires the console environment. So as
this way
layer.
This way, doing ZIO service and providing the type that you need, ZIO will detect which dependency you're needing here, and you can instantiate it and use it to pass it to the logger implementation that is required a console. And this way you build a ZLayer from a ZIO value. In this case, input will be a ZIO value.
Yeah, that's actually a very easy to use part of the ZIO library, that just by calling ZIO.service, it gives you that instance of the console. And in fact, the ZIO library, if you run a ZIO app, it will give you the console service layer automatically anyway. You won't actually have to instantiate it. The console is included in every ZIO app.
There are more ways to build ZLayers. Can be, for example, the database implementation can need different parameters, maybe a more complex one. And this is like a recipe for instantiating a ZLayer that requires two instances, for example, two dependencies. For example, in this case, a logger and a config for building the database. The database is the success type, and this environment of the ZLayer, we need the logger and the config. And we use the same recipe that is called the service pattern, using an object and a val_live to build this dependency. So you construct a ZLayer using the apply method, and you grab the dependencies you need for constructing the layer, and then you, for example, succeed in a ZIO value constructing the implementation.
So there are other ways as well. Do you actually keep going down? You show the different ways to create. So far that's from, you said, the service pattern, but you can also create from simple values, from other ZIOs, from functions as well, and allocate resources. What's this?
Yeah, it can be more complex examples that you need, for example, to keep track of how many lines you're printing in the logger. Then you have a logger with line counter, then you have a ref, and more complex things for the layer to do. You can replace one implementation with the other, and this is also useful for testing, right, Daniel?
Exactly, yeah. So this, in fact, I've done a video previously talking about the use of ZLayers with testing, because this is again direct dependency injection. We could inject a different service into, say, the class or function or module that we are testing. So instead of giving it an actual database environment, because databases are bulky and hard to spin up, we can give it a stubbed class instead, which just uses something simple like an internal hash map instead of an actual database instance. So according to the effect, it's getting the same thing. It's getting a database layer, but the actual functionality underneath could be something much simpler, some stubbed behavior. And in fact, I've utilized this to create different test scenarios before, where for the same effect, the same function effect, I've given it two different environments. One with like a repository which always succeeds, so you send it a create method and it will always succeed, and another one which always failed, so I could test failure scenarios as well, or ones that always takes too long, that maybe triggers a timeout as well. And so yeah, with this, just changing the ZLayer, the environment part of it, you can test a much wider range of test scenarios very easily and very quickly.
Yeah, here, for example, we have this example more in detail. We are using ZLayer scoped to use resources inside the construction of a layer. We require a console and we return a logger. So this is an example to have a logger that counts the lines. Let me show you just how one very good feature of the ZLayers, one of the most interesting features. How do you provide layers, dependencies into the layers? Here we have an example. We have a user service. Here we have the user service, and we are providing all the dependencies the user service need in order to build a new layer. For example, we have the config, the logger leave, that is the logger dependency. Then we have the database, for example, the same pattern, the user repository, and the user service. It's always using an object, a companion object, and a live val to hold the construction of a layer. But what happens if I delete one of the dependencies and provide one thing less?
So yeah, this is a common thing that happens when you're first writing the code, and maybe you're not quite sure of all the requirements that your application needs, and you're probably missing one or two different layers, aren't you?
Yeah, for example, here you will see there is an error, compiler error at this line, and the error is very helpful. It's saying, please provide a layer from the following type required by the logger leave ZIO console. So we are needing the console here. So, and if I remove, for example, the database from the dependencies, you will see another error that says the same, but it's the database that is missing this time.
Yep. And also say something about the function you're using to provide the layers, the actual provide method. There are several provide functions. There's provide some, provide, I can't remember the others actually.
Provide some.
Yeah, there's provide some as well. But the provide method is very much a piece of magic produced by the wonderful ladies and gents who've created ZIO, in that the services, actually even the ones you've shown there, it has created a dependency hierarchy. Some dependencies require other dependencies, which require other dependencies, and it can be quite hard to figure out to pass in the requirements for all these layers manually, because it's just a network of different layers. But the provide method right there will auto magically resolve all of that hierarchy nonsense for you. You just throw in all the requirements you have, all the requirements you need, and it will sort it out itself. So for example, the user service requires a user repository, which requires a database. And you haven't directly fed the database to the repo to the service. You've just thrown it into the provide method, and ZIO magically sorts it out itself. And this is a massive help, because when I first started, I did try doing it manually myself, trying to sort out this hierarchy, and I wasted a lot of time, and it didn't work. Even for a very simple application, it was really hard until someone else at Hivemind told me that you could just throw it into provide, and ZIO will handle it completely itself. It's a really nice piece of functionality from ZIO there.
And the good thing is that you can grab this kind of errors at compile time before running the application. So this is very important.
Yep.
To signal.
That's the strong part of Scala and ZIO. The strong typing means, yeah, a lot of these issues are caught at compile time. Excellent. So we've talked a lot about how to create ZLayers, but shall we talk briefly? We've kind of hinted at it. What kind of objects and classes are typically found in the environment channel? What typically would you make ZLayers? ZLayers of? So you've shown here typically database access is a big one. So the database layer, the repository layer, and the service layer. So the way I see it is generally anything which can have an effect outside of the application should generally go, yeah, will require access somehow. So you will go in the environment channel. So also something like Kafka. Oh, it's also something you can view as a database, I guess. Anything sending data outside of the application.
Yes, for example, database configuration, you can build this as a dependency, and you can change it for testing. You can have a different configuration for testing, for example, using a different database or a different password, for example.
Exactly, yes. Configuration as well. Sometimes I do get confused about what could just go into, if I've got, say, a class, what goes into the class's maybe construction parameters, construction variables, and what should go into an environment channel. And it's really a question of, are you trying to do things the ZIO way or the old-fashioned Scala, even Java way, which was perhaps, a class with construction variables would be more something object-oriented programming, right? Whereas ZIO were trying to be much more purely functional. So more and more, I'm starting to see things in the perspective of what goes into the environment to run an effect, to run a function. Whereas the function input parameters might just be just kind of dynamic values, like user input values, as opposed to database access configuration.
Yeah, for me, if I can mention this, I always use traits for specifying the interface that these dependencies should have. You can use a layer to construct this instance of the database, but here we don't mention anything about the implementation. And only if we go to the different implementations, for example, we have one for database, then you require all the things you need in the constructor, for example, the parameters or the logger, and only then, not before, and you extend the trait, the trait to implement the, well, to do the real implementation of the trait.
That's good. So let's go to the main class of your application and actually demo the entire application now, because you've got a lovely demonstration at the top level, don't you? In the main.
Yeah, we have a main
Yeah.
application.
So typically, with a ZIO application, through all of your modules, you'll be kind of building up this hierarchy of all the layers, and then right at the top of your program, in the main, that's where you would, around that area, instantiate all the service layers you require and feed them in to that single effect, which encompasses your entire app, which is what you've done right here.
Yeah, you have the my app logic is this method here.
Yep.
Or this private val.
Because it's an effect, yeah. So
it's an effect that requires these three things. may fail with an IO exception and returns a unit. And then here in the run method of the ZIO application, you provide all the layers, all the layers you need to run the application. So you have the logger, the ZLayer. Here you have a simple ZLayer that is the console that is just constructed with the succeed method that was missing from the explanation. Then you have the different repositories and services, the database and the config.
And again, yeah, you've just used the provide method and it's resolved that whole hierarchy of different
you transform this signature here that you require all those things into this that has no requirements for the environment and can fail the same or return a unit.
Yeah, that really demonstrates, yeah, that you have indeed provided all the requirements, because now this effect, the run effect, doesn't require anything else. You can just now run it and it will resolve. So shall we hit the run button and see what we get? This is a short simulation, isn't it?
If we want to explain here, we are grabbing the different dependencies of the application, the logger, the user service, and the property service, for example. Then we find a user using the user service, and then managing the exceptions and so on. Let's find it. Yeah, here are the print lines. Alonso Church is having a car with a price and so on.
Yep, so nice little simulation of the app using a lot of the modules that you've created.
Yes, I was watching here. There is one more feature that is at compile time that is very handy. You can uncomment this line, and you will have a graph tree at compile time in an error message. This is all the structure of the application. For example, the logger requires a console, user service requires a logger, user repository, a logger, database, another logger, and a config. And the property service requires all those things.
That'd be very useful, yeah, to perhaps tracking down where some of the real requirements are coming in from, for debugging.
And if you do the other uncomment, you will show a dependency graph into a diagram. For example, let me see. If I copy this link here, let me see if I can grab it. If I copy this and paste it here, it should show a graph. Yeah. My graph that you can edit. For example, for documenting your application, you can edit here the lines, the arrows. But this is the main structure of the application.
Yep. So you can see, yeah, just with a simple application as this, even the dependency hierarchy for this looks a little bit messy, which is where the provide method is so valuable, I feel, because ZIO handled all of that complexity itself and saved us a lot of hassle.
Yeah. Okay. Well, that's all from my side.
Excellent. So yes, thank you everyone for joining us today, and we hope that the article as well. Be sure to read the full article as Ignacio goes into greater depth on all of the topics we've talked about today. So you can find that at Hivemind's Medium page at Hivemind_tech. You can also check out our website linked below, and as well as the GitHub repository where Ignacio has pushed the application for you to clone and play around with yourself. And that will be linked below in the description. So yes, thank you Ignacio for the wonderful, insightful look into ZLayers.
Thank you, Daniel.
And thank you everyone for watching, and we hope to see you again soon.